friction of different surfaces. For the procedure, first, the mass of wooden block was measured and recorded as M. Next, the apparatus was set up as shown in figure 5.2. That the tabletop was stable and horizontal to the ground. Then, the spring scale and the wooden block was attached with a string and placed it horizontally on the tabletop. The rubber side of the block was faced downward. Next, the 50-gram mass was placed on the wooden block. Next, the spring was pulled slowly. Once the block was started to move, the spring scales was recorded. The value was recorded as F in table 5.1. Then, step 4 until 5 was repeated for 3 trials. 50-gram mass was added on the wooden block and step 5 to 6 was repeated. The steps was repeated until total of mass 500 gram is on the wooden block. Last, step 1 until 8 was repeated with the rubber side of the block facing upward.
From of this table, you can see that we are using different mass starting from 50 gram to 500 gram, and we use wooden rubber surface towards the floor with the mass 500 gram. We can compute that static friction force will increase from 0.87 to 3.692. And this is the result for non-rubber surface towards the floor. We are using the same wooden block with 500 gram mass. The mass we are using are same, which are setting from 50 gram to 500 gram. The average static friction force we get is increased with 0 for 50 gram of mass and 1 Newton for 500 gram mass.
Let's move to the the force that generated by two surfaces that contact and slide against each other. A few factors affecting the frictional force. These forces are mainly affected by the surface texture and the amount of force propelling them together. Static friction is involved in this experiment. The static friction is the friction that acts on an object that is at rest, and the static friction is also the force that must be overcome in order to move a static object. The maximum value of static frictional force is given by F maximum equal to -1 times by N, where -1 is the coefficient of static friction and N is the flow force. The coefficient of static friction is a dimensionless constant that depends on the object and the surface it is laying upon. In this experiment objective, we are trying to determine the coefficient of static friction of different surfaces, which are rubber and non-rubber surfaces. In this experiment also, the result was obtained and it was to support the theory. The result showed that the frictional force will increase if the total weight was increased too. There was a certain possible source of errors in this experiment, which was when calculate and give an force effect, but not large enough to affect the result. In addition, parallax error was one of the reasons why the result was not accurate. The measurement of an object's length is more or less than the total area of our parametric position at an angle to the measurement mark.
With the use of this experiment, we may compare the static friction coefficients of various surfaces, including rubber and non-rubber surface facing the ground. From this experiment, we may infer that friction is a force that prevents motion when the surface of two objects come in contact. The texture of the surface and the amount of force pressing them together are two additional elements that affect frictional force. We also discover that the frictional force will be equal to the weight of the object if the wooden block is put flat against against the top table.